Okay. All right. We deeply apologize for the glitch that we had. While we are trying to resolve Dr. Acha's challenges, we'll quickly move over to the next session. And our next session is Python packages for statistical research, Statsmodel packages. And it's my deepest honor to introduce our next speaker. His name is Mr. Oluwatunmise Jiboku. He's a research analyst and data professional with over 3 years of experience in conducting comprehensive data analysis and generating impactful research reports. As an economics graduate, Oluwatunmise has a strong foundation in data-driven methodologies, statistical techniques, and research-based insights that are vital for strategic decision-making. He's currently he's currently a learning and development programs manager, and he has spearheaded training programs and managed training initiatives with proven successes. His career includes notable achievements, including training data analysts from beginner to intermediate levels at Hankali Intel. He has a passion for human capital to empower others through education services, and is driven by a deep commitment to fostering growth, knowledge, and personal transformation in individuals, enabling them to unlock their full potential and make meaningful contributions. So please join us as we welcome our next speaker, Mr. Oluwatunmise Jiboku, to take us on the next session, Python packages for statistical research. Tunmise.
Thank you very much, Elvis, for that resounding introduction. Please, can anyone hear me?
Loud and clear.
All right. Thank you very much, Timmy. Let me see if I can get my video up. Okay. Okay. All right. So I'm just going to share now. I think we have a question. There's a hand raised. Yes, Chidima, please go ahead. You can send a message via the
Sorry,
chat.
Chidima, you can drop your question on the chat box.
So I'm going to share my screen. Just give me a minute. All right, so we're going to go into, I hope we're excited. We're going to go into Python for statistical research. And I am Jiboku Oluwatunmise, and I'll be taking this session today. We're going to have a very brief session, not, excuse me, not something too advanced and not something as beginner level. Although we can't really say there is anything at beginner level anymore because the way AI is going, you can see from Michael's session, there are about, I think, 2 or 3 statistical tools that he presented, and those statistical tools, they were all being run by AI. So all those tools were just AI in itself analyzing data. And I want to let you know that 3 years ago, that was not possible. So that just shows you the length of advancement AI is going. And I don't want to get into the gibberish right now, but I want to focus on this this session on Python for statistical research. About me, okay, today's agenda is going to be something very brief. Like I mentioned, ever done research here, or maybe even your research projects in universities and so on and so forth, you would have used some certain tools, maybe eViews, maybe SPSS. Some of you probably Excel. If you're talking about using survey data for your Excel, some of you might have used Excel. Some of you might have even gone ahead and used tools like R or Power BI and even Python. And specifically for today, we want to cover how to uncomplicate stats models. I know from an outsider's perspective, when you hear stats models, it might sound a bit advanced, it might sound a bit complicated, but what we want to do now is we want to see how to simplify that, right? And after that, we want to know, why would anybody choose Python over Excel or SPSS? I mean, if you are learning a tool, right? If you are learning any tool, if in fact if you're learning data analysis from the beginner level, the first thing you would want to learn is probably either Excel, Google Sheets, Power BI, sometimes even SQL. Like Alex the analyst started from SQL. You can even go to eViews or R. A lot of people avoid Python, right? Probably because it's a programming language. But we want to check, we want to verify why anybody would choose Python over Excel or SPSS. If you remember at the beginning of Michael's presentation, not at the beginning, maybe middle, he mentioned that a lot of people nowadays are using Python as their major data analytical tool or data science tool. And there is a reason why. Now we want to, after that, we'll go into practicing Python for research. Then we would summarize our this brief session for today, and then we would close. Right? If there are any questions, please do not hesitate to ask. You can send a chat. If I do not probably grasp that, you can raise your hands, react in any way, and I would see if I can answer you. Right? So about that. Okay, so about that, I'm going to just go into. Okay, let me just introduce myself. Although Elvis has done an astonishing, basically summarized what I wanted to say. I'm not going to go too much. I'm just going to let you know that I am very much interested in AI and the development of data as well. And I believe human capital is something that economies can leverage to become better as a society in general. Human capital basically is about how to enhance the abilities and the skill sets of people, right? So that they can contribute. Even if they themselves want to make money, to make money, you need to solve a problem. So if you are solving a problem, you are indirectly contributing to society. So to be able to give people these skills that they would be able to contribute to to contribute to the society is my personal purpose, and I hope to be able to do that for as long as I can. So that is just it about me. Let's go into today's session. Now we want to go into an overview on Python for research, right? So we want to just go into an overview for Python for research. But before we go into, I want to reiterate that when you're doing research, your end goal, more about 60% of the time, you have your end goal at the back of your head, right? So you already know that, you know, for instance, you have a question you want to answer, and you have like sort of like your hypothesis testing, where you have like where you have what you think is the answer to that question you want to answer, right? So that is what we want. That is what research is about. You have something you want to answer, and you want to answer that question through research. Some people might just go on Google and type something, and they've already done their research and they've gotten their answer. Some people might use pick an AI like Michael introduced, and they've gotten their answer. Some people can use the Ancalis data profilers, and they've gotten the answer. Research is just basically answering a question from maybe an intuition, from an observation. You want to answer a question, and every single day of our lives we have a question. There is always a question that we have at the back of our heads that we're always constantly trying to answer. And to answer that question, you need to research. So imagine a situation whereby your question is like very large, right? So you have a big problem. You want to solve a big problem, and this problem is quite large. And to solve this problem, you need data. To solve this problem, you need data. Now, imagine if your data is something that is going to cover. Nigeria has 36 states, for instance. So let's say your data is covering the entire 36 states of Nigeria, and your data is covering all the profiles of perhaps the bankers in all 36 states of Nigeria. That is a very large data set, right? I think in average, there are about, let's say, 50,000 employees per bank in Nigeria. So let's say in this instance, we're going to have about over 500,000 employees or profiles for the entire 36 states. So if we have that data and we are going into things like Excel or SPSS, to solve our question, we will take a very long time. So that is where Python comes into play, right? And Python is just, it's an ecosystem, right? And it's an ecosystem because it has a vast amount of applications. And this is just the simple answer to why you would use Python for research, because it has various applications that you can use to analyze this data that we've spoken about earlier. That is the banker's data now. I'm using the instance of the banker's data. And we are going to now use that data to, we're going to use Python to analyze that data. And this comprehensive ecosystem allows us to integrate with other tools and technologies. Now, using Python, you will be able to analyze with a vast number of tools, right? You can even make use of SQL, you can make use of R using Python. There are certain libraries that allow you to make use of these tools. There is even tools for documentation. Assuming you want to do a research work or a project work on Python alone, you can even have your documentation within Python. So it makes it easy for you to use. It also allows you to automate and allows for transparency in your research. When you are doing your Python, it is very hard for you to, or for an external person to sort of play with your data. You can't easily, like for example, in Excel, you can just go to one column or one row or a cell in simple terms and just edit that data and change something or change a number. Python, it's not as simple. It's not simple to do that. You have to call out a data frame. After calling out the data frame, you have to find a way to call out the column. After you call out the column again, you now have to find a way to call out the row number of where you want to change. So it's not easy to change a particular cell number unless you want to use an external application. And I'm not going to go into that because that does not cover today's class. But that is how it allows for transparency, and it allows for automation as well. When you're using Python, you can easily use the same scripts that you've used over and over and over again. You can use it multiple times. And as you're using it multiple times, you are basically um, as you're using this multiple times, you are basically saving yourself time and stress, right? So you've created one script and you're going to a different script and you're basically saving time and stress when using that Python script. And it allows researchers to handle a large and complex data sets. Like I mentioned earlier, about 500,000 data sets, right? So Python allows you to handle that large and complex data sets. You won't be able to handle over you can handle it in Excel. I think Excel covers about a million or so, thereabouts. But the processing won't be fast. It won't be as fast as Python. Same thing for SPSS. It won't be as fast as Python, right? So it is very simple to use Python for large data sets. And even when you're using your large data sets, you can conduct advanced statistical and analytical techniques. You can build a model, a statistical model. You can predict using that statistical model, and you can even analyze the data using the statistical model as well. We're going to go into that if time permits us. Um, Now, all these data bullets points submit into the flexibility and the productiveness of Python. Very flexible. You can use Python for a various number of things. I won't be surprised if it was Python that was used to create that Pecan AI that Michael was talking about earlier, right? So it's just that flexible, right? It's just that flexible. You can use Python for software development, and the next slide. There is a quote that I have, and that's from Stack Overflow, and it says that the growing use of Python is for data science, machine learning, and academic research. So you have Python, that is a programming language that is used for data science and machine learning, which are actually programming-based functions. Then you have academic research, which actually is not a program-based function. Now, at the beginning of the session, I mentioned how 2 years ago we couldn't conduct data analysis with Python. I mean, with AI automatically. And now we can do that with even ChatGPT, right? In fact, some of the images in this presentation, it was ChatGPT that presented it. We couldn't do that 2, 3 years ago. That was not possible. That is just telling you how quick AI is advancing. And the reason why AI is advancing is not because of human beings are advancing. No, right? Human beings have been on the same level. Einstein, I think Einstein has the highest IQ of 160. I don't think human beings have passed that IQ. But the thing is that when human beings are working together to create an AI like Python or AI in general, right? So Python is learning from a vast amount of people and it's just one tool, right? And because Python is learning from a vast number of people, now there is a research that I saw that it says that AI on its own has an IQ of 155. So AI's IQ is just 5 points below Einstein. Basically, it's more intelligent than a number of human beings that we have. That just shows you how quick AI is advancing. And I'm sure in the next 2, 3 years, it should probably be able to do more than it can do right now. And that's just to show you how quick things are moving. Right. So I'm sure I've told you on why to make use of Python for research, but Statsmodel still sounds a bit complicated. It sounds like math. It sounds complicated, and I get that, right? The truth is, Statsmodel is actually created from another Python library called SciPy, and it's what was done was that they removed the models part from SciPy and use it to create Statsmodels. Then they use the other part of SciPy for a different a different library entirely. So Python works with mini applications called libraries, right? So these are mini applications because they allow these are mini applications because they allow these are mini applications because they allow the library allows Python to make use of different functions. For instance, now the SciPy, right, had another function called neuron imaging, right? And this neuron imaging is different from statistical modeling. So they separated those two, and one part of SciPy became Statsmodels, the other part became NiPy, right? So I'm sure that sounds more advanced than Statsmodels, but in summary, Statsmodels just allows users to perform statistics in Python from the basic descriptions to modeling and forecasting. So using Statsmodels, you can get your mean, your median, your mode, standard deviation, and things like that. But we're not going to go into those aspects. We're going to go into something a bit more intermediate, but not advanced. So Statsmodels, that's the basic function of Statsmodels. It allows you to perform statistics in Python from the granular level of statistics to the more advanced level of statistics, right? And it is quite powerful. And this is powerful because it allows you to do your regression analysis, your hypothesis testing, your time series analysis, your predictive analysis, and so on and so forth, right? So there are so many different types of analysis that you can do using your Statsmodels. Um, Despite this, I'm sure you're probably wondering if you do research frequently, these are things SPSS or Excel can do, right? And I know that these are things SPSS or Excel can do, and then you're probably wondering, okay, so why should I now make use of Python over SPSS or Excel? Well, like I mentioned before, the comprehensiveness of Python and the ability to integrate different data sets and the ability to work with larger data sets as well. I mean, integrates different application and work with larger data sets. That simply makes it better than Excel or SPSS, right? It is more efficient when handling data. When we talk about managing large and very depth data. Python can analyze larger volumes of data. It exceeds Excel and SPSS's capabilities in doing so. The fact that it is able to integrate things like pandas, numpy, which are also libraries in Python. The fact that it can integrate those libraries alone, right, allows it to do things that Excel or SPSS simply cannot. For instance, the ability to define functions and loop within Python, right? That is something that allows that alone is just something that makes it better than Excel or SPSS, right? And it integrates data into technology seamlessly, right? So using Python can integrate data. So you have your data sets, right? And your data sets can be connected into perhaps a data pipeline after you model your data, after you analyze your data, and you basically walk around your data to get the results you need. You can fit it into a data pipeline and you can further input it into perhaps maybe a web application, excuse me, perhaps maybe a web application or a a tool or any other software you want to make use of based on the Python scripts that you've done. You can also customize your scripts for different unique tasks. So we talk about Pecan AI now that was able to analyze data automatically. You also had, forgotten the name of the first tool Mike mentioned, but was it ThoughtSpots? So these different tools, right? They are performing similar functions, but they are not similar functions. You even have the data profiler as well that is performing a different function. So these are unique tasks, but they were created using a Python script. So that just shows the customizable ability of Python, right? It has complex visuals that makes it better than Excel or SPSS. So the visuals in Python, I'm not saying they are more aesthetically pleasing. No, they are more complex based on the fact that Python's visuals allows you to see things that are more statistically inclined than Excel or SPSS. While SPSS, yes, is originally a statistical package or a statistical tool, um, it is not as advanced in visualizations as Python, right? And Python and this is because of Python's integration with different mini applications, in this instance called libraries. Python works with Matplotlib or Seaborn, and these two mini applications allows you to visualize data in different instances. We've spoken about the ability, how it makes it to automate in Python. And we also have the community, right? Unlike Excel and SPSS, and in fact, Excel is better than SPSS, Python has a very large community. The fact that we are all in this meeting right now talking about Python, while which is a programming community, and Python takes advantage of that programming community. And the advantage Python takes is that programming community asks questions. The people in that community, they ask questions based on how to use Python. So if Python has um, uh, updates, so Python gets regular updates. So if there's an update in Python and somebody wants to make use of the new updates to probably work around their Python scripts or to work around their data sets, they can ask a question in Stack Overflow, for instance, and they would get an answer. It may not be immediately, but they will get an answer based on somebody that has probably performed something similar before. So that is just why these these bullet points allow us to know Python is actually better for statistical analysis, data analysis, um, maybe not visualization, but statistical visualizations than Excel or SPSS. Um, so that is why you should use Python over Excel for research, right? Because we're talking about research now. So that's why you should use it for research. And now we want to just quickly go into a bit of a practice section of how to conduct linear regression using Python's stats models. Yes, we're going to make and it might sound a bit advanced, but really, honestly, it's not. It's quite simple, and once you grasp the fundamentals of it, because the fundamentals are the most important thing. Once you grasp the fundamentals, you will be able to do any other thing after that. So you focus on learning the fundamental aspects, and before you know it, you can even be on your way creating your own Pecan AI or ThoughtSpots or data profiler as well. So I'm going to share my Python scripts. I have already worked around this a bit, but the problem is that okay, just a minute, please. So the problem is I'm just loading my computer. Just give me a minute. Because of time, I think I have about 15 more minutes to go, thereabouts. So I'm just going to share my scripts. Right. So when you're working with Python, you need to take note of the libraries you want to use and why you are using that. I'm not going to make use of this. Right. So you need to take note of the libraries you want to use and why you want of these libraries. When you're learning Python for the first time, now this is not a beginner's class. This is more a bit of an intermediate class. Um, if you want to go into beginner session, I think perhaps if you want to learn Python for data analysis and data science, perhaps you can message the Ankali team. I think they have um, communities and uh, communities and videos for that. Now, this is a bit of an intermediate class. I'm not going into what pandas are or what numpy is. I'm just going to go straight into the statistical aspects of it, right? Because we want to do research, right? And when you want to do research, like I said earlier, you need to know what you want to do, you need to know why you are doing it, and you need to have basically an end goal at the back of your head. So when you're importing your libraries, you already need to know why you're importing them and what you want to use them for. These are why the fundamentals are quite important in almost anything you do. So the first library here is pandas, and pandas are used for data manipulation and pre-processing. Then you have the numpy, right? Numpy is similar to pandas, but unlike pandas, pandas works with something called data frames, and data frames are like Excel's columns and rows. Then numpy works with matrices, and matrices are more for advanced mathematical functions, more like linear algebra and so on and so forth. You also have your Seaborn and Matplotlib, which I mentioned earlier for visualizations. Seaborn works more with statistical visualizations, while Matplotlib is more statistical and it has basic data visualization functions as well. Um, okay, I think there are questions. Okay, Mike has helped answer that question. Right. So we also have scikit-learn, right? And what this particular line of code is doing is splitting the data into training and testing, right? And this is where you have your stats models here, right? And what this stats models is saying is we're telling Python is that we want to work with statistical modeling, right? And to work with statistical modeling, we want to make use of our Statsmodels mini application, or in this instance, library, right? And we're importing that as SM. So take note of these abbreviations here. These abbreviations are the abbreviations for your pandas, your numpy, for your libraries in general, right? They are what we're going to use to extract items from the library. So I use stats models in 3 instances in these lines of code. And you have compact, and this is basically to compact the statistical functions. So sometimes you might have a robust stats function, and you want to just reduce that, and you want to just make that you want to minimize that. So this particular line of code here does that for you. And you also have the ability to run statistical tests. So after you've done your modeling, you've probably ran your model, you've worked on it using the data. You want to check if it fits your statistical tests, or if it's, I mean, if it fits the criteria to be used. And to do that, you need to perform your statistical tests. So your statistical tests will allow you to know whether the model that you've created fits the criteria. You also have, I have mentioned scikit-learn for training and testing. Uh, to explain this better, I sort of need to actually do this. So when you are working with statistical functions, especially in Python and data science, it is preferred you break down your dependence variable and independence variable into um, training and testing data sets. And the training and the testing, what they do is they allow you to train and test the independence and dependence variable fitting through your statistical model, right? And you fit your training and testing data into your stats model to know whether your model is accurate, whether it can be used for the reason you want to make use of it. And you would now use your statistical testing to confirm if if the model you've created and the data, right, that has been run through the model fits the criteria, the minimum criteria, because there's going to be a minimum criteria. So you want to know if that data fits that minimum criteria. So this allows you to assess the performance of that splitted, the aforementioned training and testing data sets that has been mentioned earlier. You also have your mean squared error. So this basically, what these particular items do, your mean squared error, adjusted adjusted R square score, and your mean absolute error, they are used to just test the model. They are evaluating the model, right? So you've performed your tests, and now you want to evaluate if that model is actually functional, if you can make use of it, if you can do better, or if you cannot do better. So that's why you are evaluating that model. So we're going to run this. We're going to just run this. Right. Just give it a minute. All right. So it has been run. And now we want to get a data set, right? And because this is Google Colab, I initially wanted this to be a hands-on session. I don't think I'll be able to have time to have a hands-on session. However, probably after today's session, maybe the Ankali team can send you this script and the data, so you can also play around it and have a more of an understanding, because practice makes perfect. You can't get better without practicing. It's not possible. So we want to now import the data sets into our Google Colab. So I'm working online. This is I don't want to go into the beginner aspects, but this is an IDE environment called Google Colab. Um, uh, Michael mentioned Jupyter Notebook earlier. So there are many environments. People can be more familiar with VS Code Studio. So there are many environments that you can make use of Python. Even Cargo, you can make use of Python in Cargo. But wherever works for you is what you use. I wanted to use this so that it can be hands-on for this class. But that would actually take more than an hour. So let's just focus on this for now. So assuming we want to now import the data set into the Python, the Google Colab. This is the function we make use of from Google Colab import files, import IO. Then when you run this, it's like basically creating a application that where you can upload a data set, right? You can upload your data set into choose a file, right? I'm going to choose a file, and I'm going to work on a file called life expectancy. I've selected that now, and all right, sorry about that.
Oluwatunmise, are you there?
Sorry about that. I had a network glitch. I'm just going to share my screen once more. Okay, right. So I'll have to rerun this. I'll have to refresh this actually. So I'm going to run this again. Wait, is it audible? I am getting comments that it's not audible enough.
Yes, it's audible now.
Okay. Thank you, Terry. I'm just trying to sort of, I don't know, the code is, I'm having, I don't know if it's even network issues or I don't know what issue I punch this out at this point. Right, so I'm going to reload this. Um, I seem to be having network problems because the current ID is it's online. So because it's online, I need internet, but I don't know. I have internet at the same time, but doesn't seem to. Okay. Okay. I think we're back. Okay. So I just run through it real quick. There seems to be a lag. There seems to be a lag with. All right, but you can see the life expectancy. We're making use of a data set called a life expectancy, and what this life expectancy data set does is it checks life expectancy of I think the globe, right? Different countries in the world, basically using different independent variables that constitutes factors that can affect life expectancy within that country. So this is how you call out the data set into a data frame. So when you have your data sets, when I mentioned earlier, I mentioned how pandas worked with data frames. So it's not easy. I mean, it is complicated if you are doing statistical modeling and you are not able to work with your data frames. That can make it harder for Python to understand what exactly you are trying to work with. By the time I load this, so you can see this is pd.read, and what this is telling Python is what we want to read our data sets into a pandas data frame, right? So currently our data set is a CSV file, and by the time I run this line of code here, pd.read underscore CSV, I don't want to get into that, but by the time I run this, you can see the data frame has been printed out, or the data set. And this is what I was mentioning about the country. You even have the status, whether it's a developing country or a developed country. So you have your life expectancy, which is actually your dependence variable. And dependence variable are sort of let's say in this instance, your dependence variable is like a figure that is dependent on other variables. So in this instance, you can't have life expectancy. The life expectancy of a country um, is factored by all these, from adult morality here to um, schooling, right? So all these factors constitute reasons why your life expectancy for Afghanistan is probably 65, right, in 2015. So you have that factor there, right? That is why that's your dependence variable, and these are your independence variables. Your independence variables are standalone, right? Your independence variables do not need your dependence variable. You don't need life expectancy for alcohol, right? You don't need life expectancy for to spend money, right? You don't need life expectancy to contribute to factor in your GDP. But when maybe the UN or whichever organization was creating life expectancy, they needed those variables to create and to get that life expectancy. So now we want to actually test, okay, a is there like a correlation between life expectancy and all these variables? But we can't use all these variables because we have 22 columns and we have a lot of rows as well. Um, so we can't use all these columns, and we have about 2,000 rows. I'm going to show you that when we get to understanding the data sets. But I want to just touch points on the life expectancy and how it's a dependence variable, because it's quite important we understand this. As a dependence variable, I'm going to mention it again. It does not need all these other. It needs all these other factors. But we're basically testing. Oh, life expectancy is being dependent on all these other factors, right? And all these other factors are not depending on life expectancy. For conducting your regression, you have a formula. There's a popular formula everybody knows. People that do regression on a consistent level. That's the y is equals to mx plus b, or you can have it can go a bit further and be a bit statistical. You can have your y is equals to x exclamation mark x, put that into a square. I don't want to get into that, but it can be get a bit more. We can fit it into a matrix as well. So that is your regression equation, and in this instance, your life expectancy is your dependent variable, right? I just want to make that clear. So your life expectancy is your y, while your from the adults and above they are your x. So we want to understand this data more, because whether you are doing your modeling, whether you are doing data visualizations, whether you are doing predictive analysis, time series analysis, you need to understand the data sets. You need to understand the why you are doing what you're doing. So this particular line of code allows us to get the information of the data set. By the time I run this code, I get a bunch of details about the data sets, right? And you can see country starts from 0, right? And that's because Python starts its counts from 0. Python does not start its counts from 1. it always starts its count from zero. And I hope this is not a bit complex. If you have any questions, please, if you have any questions, please let me know in the chats. All right, let me know in the chats. So zero starts from zero is always the first item, right? Zero is the first item, while one is the second item. Because you can see from here as well, zero was the first row and one was the second row. So Python is always starting its counts from zero. Zero stands at one. So we're talking to a computer, right? So as we're talking to a computer, we're talking to a computer that starts from zero, one, and thereabouts, and it continues like that. So from this now, we can see that there are 22 columns because all these outputs here are columns. But from here, we can see there is a variance. And what this is saying is there are 2,938 entries for country. There is also that similar number for year, status, up till infant's death. But by alcohol, we get 2,744. And this is different from um, the 2,933 that infants deaths and to country have, right? We also get another variance answer with percentage expenditure, similar thing for hypothesis B, and so on and so forth. So what this means is that most likely um, there are no there are no cells within the data frame, right? So we have no cells within the data frame. And we want to be sure of what the shape of the data is because we have 2,938, we have 2,904, we have 2,712. So too many different rows for different columns. So we want to confirm what the shape of the data set actually is using this df.shape. And we get our shape, which is telling us, yes, there are actually 22 columns, and there should be 2,938 rows, right? So we have no values within some of these rows. Now we want to describe the data sets, and what this particularly does is gets important. It gets important important statistics about the data set. So you're working with your data set, and you want to get the important statistics. And when you're talking about statistics, you're talking about integers. Now, integers are basically numerical outputs. So from this information that we have here, we see objects, we see integer, we see objects within floats, we see floats, we see integer. So floats are decimals, while integers are whole numbers. Then objects are more of strings, but yes, objects are basically more of strings, but sometimes they serve as maybe true or false, yes or no, and things like that. Because for status we have developing and not developing and developed rather. So what this describe is going to do is going to get the summary statistics. If you use Excel very well, or if you do analysis very well, you know what summary statistics is. It's going to get like similar to your summary statistics for the floats and the integers. Now, by the time you run this, you have the summary statistics of this data set, right? And you can see that you have the year, you have the count, you have the mean, you have the standard deviation, you have the median, you have more of like an interquartile range between your median and the max, right? You have your life expectancy, you have your adult morality, you have your infant's deaths, you have your alcohol, you have your percentage expenditure and things like that. And it keeps on going on and on and on like that. Uh, so now we have an understanding. I don't want to go into this, but we have an understanding of data sets using this. right? But just to quickly touch points on this, you can see that you have your life expectancy, which is a dependence variable, and you have a bunch of other independence variables. But I want to make use of economical variables, right? So I want to make use of economical variables, not because I studied economics, but just because I just want to know if these economical variables actually have an impact on their life expectancy. Because what does GDP have to do with life expectancy? If we're being honest, if you are talking on a granular level, what does GDP have to do with life expectancy? What does expenditure have to do with life expectancy? What does alcohol percentage expenditure have to do with life expectancy? And what does some things like income composition of resources have to do with life expectancy? So these variables we want to check, right? We want to check how they affect life expectancy. So to do that, we want to model the data, right? We want to first of all create a new data frame, and this frame I'm going to call it vars. And you can see I'm bringing out life expectancy, which is our dependence variable, and I'm bringing out percentage expenditure, total expenditure, GDP, and income composition of resources, which are more or less the economical variables within the data set. Right. By the time I call that out, right, you can see this verse is get. I don't want to start explaining this. This is beginner level stuff. But what this verse is saying is bringing within the data frame is bringing out the life expectancy from the data frame, right? So you have the data frame and it's bringing out that life expectancy from the data frame. It's bringing out the column of life expectancy. It's bringing out the percentage expenditure. It's bringing out the total expenditure. It's bringing out the GDP. It's bringing out the income composition of resources. So these five columns are being extracted from your initial life expectancy data set. And by the time you print this out within a, by the time you print this out within an overarching, by the time you print this out within an overarching data set, within the vars rather, you want to print out the head, the vars dot head. By the time you print this out, you get something like this, right? And what this is saying, I think I have a lag. I think I have a lag. I think I'm lagging. Okay, so what this is saying is, I hope the lag is not too bad. And please, am I lagging? Tell me, am I lagging, please?
No, you are good. You are good.
Okay, thank you. Because I checked my phone and it seems like I was like 5 minutes slower. I mean, 5 seconds slower. So this is the life expectancy, and you can see each column has been extracted, right? You have your dependents, you have your independent variables. Now we want to remove, because we're only working with this columns. So we know we have, okay, if we just check, let me just quickly check that slide. If we just check the info, right? If we check the info, we can see that they are still not aligned to having the same number of rows. We have some rows, like GDP, for instance, is 2,490. Then you have total expenditure, which is 2,712. Your life expectancy, which is 2,928. So you basically you have different rows, and we want to drop those empty rows. We want all the rows to be the same thing because we want to start modeling our data. So we're going a bit by bit. We're working towards the statistical bit of this. By the time we run this, um, we've run this code here to drop those empty data sets, and all the data sets now summarize into 2,327, right? So we have 2,327 um, rows and columns that are filled. So we have filled cells, complete cells for this particular data that we want to make use of. Uh, okay, we don't have much left in our script. Now we want to select, and we've already discussed what our dependent and independent variables are. but we've not told Python that, okay, these are our dependence variables and these are our independence variables. Now, when I mentioned earlier, I mentioned the equation. I mentioned the equation y is equals to mx, y is equals to mx plus c. I'm going to just paste. Let me just to for you to have a visual outlook of that. This is basically a visual outlook of that function. You have your y, you have your intercepts, you have your maybe the slope and the x, right? Then you have another slope and x as well. Then continue based on how many columns you have. So this is your dependence variable. This is your first independent variable. This is your second independent variable. We have four independent variables, right? Because our independent variables are percentage expenditure, total expenditure, GDP, income composition of resources, and so on and so forth. By the time we run this, right, because we're basically telling Python that we want to attribute X as our life expectancy. We want to attribute, we want to attribute Y as our life expectancy. Then we want to attribute X as to all other um, columns aside life expectancy. So this drop is removing life expectancy from this vast, from the vast data frame. Right, by the time we run this, right, we've already selected out our y and we've selected out our x, right? And if I check out this in code, let me just check the okay, right? You can see we only have one column for our y, and for our x we have four columns. Okay, yeah, we have four columns for our x. Now we want to go into testing and splitting. We're still modeling our data, right? And I mentioned earlier that we don't use our initial data. We break it down into X trains and Y trains. And the use of this is that we are basically we're preparing our data, right, for our statistical model. We're creating a model, right, but at the same time, we are basically preparing it for, in case, let's say, we want to use that data set, this data set over and over again, right? It's better to break it down using the training and the testing data sets. And the reason being is that what this is saying is we're splitting our x and y into our x train for our x's and our x tests. So our x is going into two different data sets. It's going into your x train, it's going into your x test. Your y is going into your y train and it's going into your y test. And at the same time, you have your test size, which is 0.2. So what this is saying is that 20% of our data sets is going to be for the testing, while the remaining 80% will be for the training. So for this testing here, you have 20% of the initial, this particular out this particular data frame that we have, 20% of the total of this data frame is going to be test data, while the remaining 80 is going to be trained data for the X and the Y's respectively. Now, what this random state of 100 is saying is that for each time we load out either the X train or the Y train or whatever, we're basically rolling out as a new data set. As like I said, it allows you to do it over and over and over again. So here it says about 100 times we can do that. Now we want to convert this with to NumPy, right? We want to convert our X train data sets, our train and testing data sets basically to okay, I don't have much time. All right. Okay, so we want to convert our X and data sets to NumPy, and the reason for this is for consistency. We want to have consistency across the training and the testing data sets. So the reason why we convert to NumPy is that regarding communications, for communications to flow within number one Python, we're working with different different libraries. We're working with Statsmodels, we're working with NumPy, we're working with Pandas, we're working with um, Seaborn and Matplotlib, and also Scikit-learn. And Scikit-learn in particular works very well with NumPy, right? And we just we're going to make use of, we're going to do our modeling and our summary right now, but we also um, want Python to understand this. So that's why we're converting to NumPy, because NumPy is for advanced mathematical functions, right? And this we're going a bit more advanced than just the basic data frame and data sets. So I'm going to run this. Okay, I've not run the testing and okay, so I'm going to run that. Let's run this. So with this now, we can say we've modeled our data sets, and we want to go into fitting, right? We want to go into fitting. We want to go into um, um, fitting and summaries. I don't know if we'll be able to go into prediction and evaluation, but at least let's try covering model fits and summaries, right? Um, so we've already done our training and our testing, and this is where our stats models really come into play now. You can see sm.add underscore constant. So SM is actually the stats models. So our stats models is allowing us to fit our model, right? But before we start going into the model aspect, we want to get the intercept. So we're adding the constants into the X train, right? While we're adding it into the X train is, if we go back to our formula, y is equals to b naught 1 2. So we don't have a b naught in our data set, right? So what that is basically doing is that it is adding that b naught into your data set, right? So what this b naught is saying is that, for assuming we don't have any independent variables, we have the y is equals to b naught, which is basically y is equals to um, um, 1 times 1 multiplied by the data set, right? So y is equals to let's say y is basically equals to y, right? So but we just want to have that because that is what our model says. So we're going to have that intercept. We're going to add that intercept to the X train, and we've done that. We've added the constant. Then we're now using our OLS from our stats models to now add the Y train and the X train together. So we're going not adding them together particularly, but then fitting them into that model that we have. So the OLS already has the model embedded in it, right? The OLS, you can see it already has the model embedded in it, and it has the model because it's from stats models. So stats models already has that model, and by the time we run this, we've gotten we've gotten them we've fitted our data sets, our training data sets into that model, right? So 80% of our data sets has gone into our model, right? So we're now fitting that, right? We're just fitting that into the model now by running this code. We're fitting that into the model. By fitting is we're basically just cutting out errors, right? Assuming there are errors in the data set and we have parameters that are not going to allow our data sets to print out, um, to conduct the analysis within the OLS, that's the ordinary least square, right? Because ordinary least squares does these things where it is dividing means of least squares, right? And it does this because it's just trying to reduce errors. And to reduce the errors, it's trying to fit the data set into the model, right? So using these 3 lines of code, we've been able to do that. Now, by the time we print out the summary of that model, we have our regression results, right? We have our regression results, and this is, so what we've been doing from the beginning up to this point is basically to get our regression, right? It's basically to get our regression. Sorry, I get a bit distracted. So it's basically to get regression, and while getting our regression, we have our y squared, we have our adjusted y squared, you have your f statistics, And what are adjusted R square in particular is items that are closer to 1, right? Items that are closer to 1. Please just give me 5 minutes. I'm not going to go into the prediction and evaluation. So items that are closer to 1, it means that items closer to 1 are, R square basically evaluates based on items closer to 1. So between 0 to 1. And our output here is 0.551, right? So what this is saying is 55% of our data sets, right, fits into the model, right? So 55% of our data sets fits into the model. That's what it's saying. It also has the DF model, which is just telling us about the parameters. Then this F statistics here is telling us that it's telling us about the amount of it's telling us the amount of data points that fit into the regression model, right? So here we have about 570, right? And the probability of this probability F stat is telling us the significance of our regression model. Now, this is giving us 4 points, E3 something, and it is actually less than it's less than 0.05, and 0.05 is the minimum p-value, right? So once you have your prop f statistics going above 0.05, right, or the more it is closer to 0, right, it means your model is significant. So this is basically saying our model is significant. However, within the significance of our model, only about 55% of our data sets fits into the model. But however, it is significant. We also have other interesting statistical functions here, right? You have your Duben-Watson, you have your JRQ Bearer, and Skewness and kurtosis as well. But if you look at this 1, 2, 3, 4, now what this 1, 2, 3, 4 is saying is basically telling us that we have our 4 independence variables, right? We have our 4 independent variables, and